Hi, my name is Scott Locascio, and I am a computer engineering graduate student at SJSU. And I'm going to talk to you today about locally networked augmented reality. Okay, so basically, this presentation is going to focus on kind of what is augmented reality and how does local networking kind of come into play with it. Some problems in local networks for augmented reality, research goals, of this research, and then some proposed solutions as a result of that research. Okay, so basically, what is augmented reality? Augmented reality is a way of overlaying digital content into the real world. This can be done through mobile devices like smartphones or tablets. This also can be done using like a headset, like a head-mounted display, such as HoloLens or the Meta Quest Pro or even Google Glass. This is kind of popular in e-commerce and games currently. You can see at the left here in Figure 1 that IKEA has an augmented reality app for mobile devices where you can display what furniture might look like in your room through your smartphone's camera. So that's there are some use cases for it currently. Um, and so basically local networking comes into play here where you might have a device and instead of doing all the processing, you would have a server or a computer basically that will do a lot of the heavy AR processing that needs to be done uh, based on the sensor data your device is sending it and then send back to your device a scene with digital content overlaid on the real environment. So another way local networking gets done in AR is between devices. So this is a proposal from another paper um, called SEER, which is Scaling Experience in Multi-User Augmented Reality, and where this proposal is to have cached results, basically, where you would have saved results from a server where you request some information from a server, has it on the device. Maybe the server's busy serving other people, and you can request that same information that you want from other devices in the room, which can be very handy to reduce load in an edge computing situation where you maybe a server is at a museum and it's serving a lot of potential customers. So you could kind of break up the processing load there. So some problems in augmented reality using local networking to achieve augmented reality is sometimes the long processing times. So if you don't break up the AR pipeline properly, you might not be able to have the communication in time to make a meaningful augmented reality scene. Feedback speeds. So like if your sensors are taking something in, like your gesture, and it's wanting to respond to that or adjust the environment, if that information doesn't go back to either the edge server or another device and comes back to you in time, it might not look convincing, the scene. And also contextual awareness. So being able to know, how far away certain objects are and where content might need to be displayed, where it might need to be displayed in relation to you to be convincing, like how tall you are and where you might want something to be eye level with you. So there's a lot of information that needs to be exchanged here, and there's a lot of kind of high processing speeds that have to go on. You can see in the figure at the left that basically the pipeline is you're taking in sensor input, you're doing the processing on it, and you're getting it back to your outputs. So going through that, you have a lot of options of how you want to offload some of that work, and so how that gets done exactly can kind of change how these problems manifest. So some of the research goals that I had were to find ways of using local peer-to-peer networking to serve users and to coordinate between them, and also to allow multiple users to exchange information and experiences in an interactive way. So being able to be in the same room with users and have what are some ways maybe of being able to share an environment, and if I make changes to something in the digital content in my environment, how do other users see and experience that in real time as well? So some proposed solutions are having a software-defined networking between multiple AR devices. Basically, that would mean having some kind of a protocol where multiple AR devices can declare an environment, they can declare objects in that environment, and if I make adjustments to it, I can kind of broadcast that to other devices. being able to split up some of the computational load between multiple devices. Maybe some kind of AR content is just within one user's sphere of influence, maybe, and that user is the one making adjustments to that. And as its device processes that, it shares that information with other users in the room. So they don't have to necessarily process and watch what the user's doing. They just have to know this change happened and send over the kind of the information about the display in the environment. Additionally, devices being able to share information about the users that they're associated with so that other users' devices know that that is a user. You don't want to lay content over them. If you do want to lay content over them, here kind of are the parameters around which you might do that. So that it takes off some of the sensing load of other devices, but they don't have to be able to actually recognize that that's another user, or recognize that that's another um, person, and be able to kind of interact more meaningfully between those two people because you have just more baked in information from that the device is sharing with other devices. One example of something similar to this concept would be part of the duplicated co-reality um, uh, proposed in this paper, where what a user is actually looking at can be duplicated so that two users can be operating on the shared environment. But what this doesn't allow you to do is actually have maybe without doing any duplication, kind of have the same thing, or also being able to this is in a very controlled environment with lots of sensors. This isn't actually sharing a lot of data between the multiple devices. Okay, so here are some of my references that were used in this presentation, and I hope this was useful. Okay.